power series. Now, under this power series, suppose we wish to express sin x as a series of ascending powers of x. The series will be of this form: sin x is equivalent to a plus bx plus c plus cx squared plus dx cubed plus ex raised to 4 plus fx raised to 5. It continues like that. Now, you notice that here we have used the equivalent sign, but not the usual equal sign. The statement is not, it means that this statement is not an equation, but it is an identity. It is an identity. This right hand side does not equal to this left hand side, but we are saying that the left hand side is the right hand side expressed in a different form, and therefore the expression is true for any value of x that we would like to substitute in this statement. Now, for us to establish the series for sin x, we need to carry the values of the constant. We need to get the values of this constant a, b, c, d, e, f. So once we get the values, we just come and substitute in this expression or in this statement, then we will have gotten the series for sin x. Now, how do you go about it? Now, to start off, step one, we shall substitute in this equation. Substitute in the equation with x equals to 0. So if I substitute that in this equation, so I have sin 0 where there is x, I substitute the 0, so I have sin x equals to, it will be a plus b times 0, remember x is 0, plus c dot or times 0 squared, it is now 0, plus d times 0 cubed plus e times 0 raised to 4 plus f times 0 raised to 5. It continues like that. Now, sin 0 is 0, so we shall have 0 equals to, this will be a, then plus b times 0, this will be 0, c times 0 squared to plus 0, so all these will be 0. Therefore, we are saying that a equals to 0. Now, we have gotten the value of a. Now, how do we get the value of b? So, we shall differentiate this equation. Differentiate the equation with respect to x. We differentiate with respect to x. So when you differentiate sin x, you get cos shall have cos x. So when you differentiate a with respect to x, it will be 0. Remember, when you differentiate a constant, you get 0, so this will be 0. So here we remain with b. So here we remain, when you differentiate x squared, you get 2 dot c dot x here, then plus, when you differentiate x cubed, we have 3 dot d dot x squared, you remember x squared, then plus, when you differentiate x raised to 4, we have 4 dot e dot x cubed, then plus, when you differentiate x raised to 5, you get 5 dot f dot x raised to 4. Now once we differentiate, and then we put x equals to 0, and then substitute all through. So here we have cos 0 equals to b plus 2 point c, or 2 times c times, now this is x is 0, plus 3 times d times 0 squared. So then plus 4 dot times e times 0 cubed plus 5 dot times f times x, this is 0 raised to 4. So cos 0 is 1, so we will have 1 equals to b plus, all this will be 0 because we are multiplying with the 0, so we have 0 plus 0 plus 0. Therefore, b equals to 1. B equals to 1. So we now have the value of a and the value of b. We are saying that a equals to 0, b equals to 1. So for us now to get the value of z, we now differentiate this equation again. So when you differentiate cos x, you get negative sin x. Get negative sin x. When you differentiate, this will be 0, so we remain with, when you differentiate x here, you have 1, so here we have 2c plus, when you differentiate x squared, here we shall have 3 dot 2, this 2 times d times x. When you differentiate x cubed, here we have plus 4 times 3 times e times x squared. When you differentiate x raised to 4, here we have 5 times 4 times f times x cubed, and then we put x equals to 0, so we have here minus sign 0 equals to 2c plus 3 times 2 times d times 0 plus 4 times 3 times e times 0 squared plus 5 times 4 times f times 0 cubed. So sine 0, so sine 0 is 0, so we have 0 equals to, all these are now 0 because we are multiplying with the 0, so we remain with the 2c. Therefore, c equals to 0 because 2c equals to 0, so c equals to 0. C equals to 0. So after getting this, how do we get the value of d? We now differentiate this equation again. So when you differentiate sin x, you get cos x, but we have a negative here. So we shall have negative cos x equivalent to, when you differentiate 2c, because it's a constant, you get 0, so we remain with 3 times 2 times d. When you differentiate x, you get 1, so we have this. then plus, when you differentiate x squared, so here you have 4 times 3 times 2 times e, then times x will remain with x, then plus, when you differentiate x cubed, so here we remain with 5 times 4 times 3 times f times x will remain with x squared, and then we put x equals to 0. So here we have negative cos 0 equals to, so here we have 3 times 2 times d plus, here we have 4 times 3 times 2 times e times 0, then plus 5 times 4 times 3 times f times 0 squared. So cos 0 is 1, we have negative, so you have negative 1 equals 2. So here what we have, or this, because we are multiplying by 0, this will be 0, this will be 0, we remain with the 3 times 2 times d. Therefore, d equals to negative 1 all over 6, or negative 1 all over 3 factorial. Remember, 6 is the same as 3 factorial. So once we have done this, so we have the value of d equals to negative 1 all over 3 factorial. So we have the value of d. We can also get the value of e. How do we get the value of e? We differentiate this equation again. When you differentiate cos x, you get negative sin x, but already we have negative, so negative and negative will be positive. So when you differentiate negative cos x, we get sin x, which is equivalent to, now here, this is a constant. When you differentiate this one, you get 0, so we remain with 4 times 3 times 2 times e. When you differentiate x, you get 1, then plus, when you differentiate x squared, we get 5 times 4 times 3 times 2 times f times, now it will be x. Then we put x equals to 0. Therefore, you have sin 0 equals to 4 times 3 times 2 times e plus 5 times 4 times 3 times 2 times f times 0, because x is 0. So sin 0 is 0, so we have 0 equals to 4 times 3 times 2 times e. This is 0. Therefore, e equals to 0. E equals to 0. So e equals to 0. Now, for us now to get the value of f, we now differentiate sin x. We differentiate sin x again. So when you differentiate sin x, we get cos x, cos x, and then this is a constant, so we remain with, when you differentiate a constant, you get 0, so we remain with this. We differentiate x. So when you differentiate x there, we have 5 times 4 times 3 times 2 times f. And then we put x equals to 0. Put x equals to 0. So we have cos 0 equals to 5 times 4 times 3 times 2 times f. Therefore, but cos 0 equals to 1, Therefore, we shall say that f equals to 1 all over equals to f equals to 1 over 5 factorial. 1 all over 5 factorial. So once we have all this constant, we come and substitute in the original expression. So we shall say that sin x equals to a will be 0, then plus b was 1, so b is 1, so we have 1 times x, then plus c was 0, 0 dot x squared, then d is negative 1 all over 3 factorial x cubed, then e is 0 plus 0, e is 0 times x raised to 4, then plus f is 1 all over 5 factorial x raised to 5. So sin x equals to, so this will be x, this is 0, this is x, minus x cubed all over 3 factorial, this is 0, plus 1 over 5 factorial x raised to 5. So you can see the pattern that x is raised to 1, here x is raised to 3, here is x raised to 5. So it's like the power of x are odd and the signs are alternating. We have negative, positive. So the next, if we had continued from f equals to 5 plus g x raised to 7 plus h x raised to 8, then this the next value here will be, because negative, positive, so it will be minus, it will be 1 all over 7 factorial x raised to 7, then plus 1 over, now it will be 9 factorial x raised to 9, then minus 1 all over 11 factorial x raised to 11 plus. So that will be now the series for sin x. The series for sin x. Now, provided we can differentiate a function, a given function, over and over again, and find the values of the derivatives the way we are doing, and find the values of the derivatives when we put x equals to 0, then this method will enable us to express any function as a series of ascending powers of x. However, as we can see from here, all through this entails a considerable amount of writing. So we now establish a general form of such a series which can be applied to most functions with very much less effort. And this general series is known as we establish a general series which is known as Maclaurin's series. Thank you for listening.